All righty, here we go. Day 2, solving systems by substitution. Unfortunately, you just have me today. No guests artistes. Sorry. So let's get started. I think first slide. Oh, you've seen it before. Solve one of the equations for one of its variables. Substitute the expression. Now remember, what that means is you're going to have x equals something, y equals something. You're going to box that something, then you're going to boot whatever you have alone out. And you're going to substitute that expression in from step 1 into the other equation and solve for the other variable. At this point, you're either going to have x equals a number or you're going to have y equals a number. Well, that says 0. That's supposed to be the number sign. Goofy, goofy, goofy. From there, you're going to take that number and substitute it back into one of the equations and solve for the other variable. My goodness, my handwriting is worse than normal today. Probably because I've had a vacation. Check the solution in both of the original equations, okay? Horrible handwriting, but you've seen this before. Let's hope it gets better. So here's our first example right here. We know that y is 4. So we're going to boot y out of this equation down here and put 4 in its place. So we have 3/2 x plus, we're going to substitute in, boop, take y, I don't have the whistle, sorry. Take y out and put in 4. So we have 3x over 2 plus 4 equals 1. We're going to subtract 4. We have 3x over 2 equals -3. At this point, you either put this over 1 and do a proportion. So you would have 3x equals -6. Divide by 3, x would equal -2. Or your other option is when you have 3/2 x equals -3, you can multiply both sides by 2 over 3, and again, you get x equals -2. Either way, x is -2. Then you go back into y equals 4, and you substitute -2 in for x. There is no x, so your point is -2, 4. Now, in order to check that, you're going to take 3/2 times x plus y equals 1. Here's x, here's y. So you're going to put -2 in for x, 4 in for y. This is -3 plus 4. Does -3 plus 4 equal 1? It sure does. The other one's just y equals 4, so you're all good. Okay, once again, we have x alone, so we're going to solve by taking 4y and putting it in place of x. So you're going to take 4, you're taking x off the court, and in place of 4 or x, you're going to put 4. Why am I writing in purple? You can't see that. You're going to put 4y. So you have 16y minus 1y equals 75. 15y equals 75. Divide them both by 15, and you get y equals 5. You're going to go to the other equation, x equals 4y, and in place of y, you're going to put 5. So you end up with x equals 20. So your solution is the ordered pair 20, 5. 20 is x, 5 is y. So when you go to check it, x equals 4y, you're putting 20 in for x, 5 in for y. Does 20 equal 20? Sure does. When you have 4x minus y equals 75, you're putting 20 in for x, you're putting 5 in for y. This is so squishy. Does 80 minus 5 equal 75? It sure does. Messy, 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 but it works. So 20, 5 is your solution. All right, here we go. Slide 5 of 10. Oh, nobody solved alone. But look at this one. Remember last time we said you want to find the one that has a coefficient of 1, and that's this y right here. So you're going to take 4x plus 1y equals 12, and you are going to solve 4y. That means get the y alone. So you're going to subtract 4x from both sides. You get 1y equals negative 4x plus 12. So that's the expression that's going to go in for y on the other equation. So you go back up here, negative 2x minus 3y equals 14. You're going to take that y out, and you are going to substitute in negative 4x plus 12. So when you distribute, you get negative 2x plus 12x minus 36 equals 14. Now, y'all hate doing this little box here. I'm putting in purple because I know you don't like it. But it's a good thing to do because 2x minus 12x gives you, we won't change colors, guys, 10x minus 36 equals 14. You're going to add 36 to both sides. 10x equals 50. Divide by 10. X is 5. Oh my goodness, that's a lot of work. Now we're going to walk over here. These are going to be my little footsteps. Walk this way. Walk this way. My feet get fat as I go along. I'm going to put 5 in for x. So y is going to equal negative 4. Put 5 in for x plus 12. Negative 20 plus 12 is negative 8. So we are saying the solution is 5 comma negative 8. In order to check that, we're going to take 4x plus y equals 12. We're going to put 5 in for x. My pen is all messed up. And negative 8 in for y. Does 20 minus 8 equal 12? Oh my gosh, it sure does. So the next one, this is going to be really squishy. We've got negative 2. We're going to put 5 in for x. Minus 3, we're going to put negative 8 in for y. We want to see if that equals 14. Does negative 10 plus 24 equal 14? Yes, ma'am. Look how colorful that is. I just want to take a moment and look at that. Oh, that is beautiful. Loving it, loving it. Okay. Oh my gosh. So as I look at this, x has an 8, y has a 2, x has a 4, y has a 1. This is where I'm going to go. I'm going to take 4x plus y equals 11, and I'm going to solve for y. Remember, you're going to solve for whichever one has a coefficient of 1. You're going to take that and put it in for y in the other equation. So I'm going to go to 8x plus 2y equals 13. 8x plus 2 equals 13. What am I going to put in for y? I'm going to put negative 4x plus 11. Then I'm going to go back and I'm going to distribute. Oh, that was supposed to change to blue. I'll erase it, you goober. All right. 8x minus 8x plus 22 equals 13. I'm going to take that purple pen that you can barely see because you barely remember to do it. Ooh, 8x minus 8x cancels. I have 22 equals 13. Here is your head. Do you have no variables left? Yup. Is what you have left true? Nope. Is what you have left false? Yup. That means it's no solution. Yay! We're done with that problem. That's awfully pretty too. I am liking these colors on the black screen. Good job, Mrs. Colonis, choosing the black screen. Okay, so I'm looking at x. Oh, look, right off the bat, x has a 1. So this is what I'm going to solve for. I'm going to take x minus 2y equals 3, and I'm going to get the x alone. I'm going to do that by adding 2y. Okay, got to get the x alone by adding or subtracting. This is what's going to go in for x in the other equation. So when I go to the other equation, 4x minus 8y equals 12. Take an x out, and what am I substituting in place of x? 2y plus 3. I'm going to distribute. That's 8y plus 12 minus 8y equals 12. Purple pen. Purple pen. There we go. Box that you can barely see, but you got to remember to do it. Oh, the 8y is cancelled. So all I have is 12 equals 12, and we're going to your head. Here is your head. You have no variables left. True. Is what you have left true? True. That means it's infinitely many solutions. Remember, what that means is it's the same line. It's just two different equations for the exact same line. If I remember correctly, the next one's a checkpoint. Oh, it's not. Oh, I didn't remember very correctly, did I? Never mind. Okay, we got story problems. Tickets to a movie cost $7.25 for adults and $5.50 for students. So can you picture it? Standing in the movie line, there are some adults and there are some students. Every student is going to pay $5.50. Let's be honest, their parents are paying $5.50. Every adult is paying $7.25. Some friends full of students and adults purchased 8 tickets for $52.75. Write a system of equations to represent the situation. So you have two things going on here. You got information about money and you have information about the number of tickets. So if we're going to let A equal adults and K equal students for kids, because I don't like S. It looks like a 5. My handwriting's bad enough. I don't need a 5 and an S to get confused. So what I've got is I've got a bunch of adults plus a bunch of students going to the movies. How many are in that bunch? Well, if they purchased 8 tickets, I bet there are 8 people. Yeah, yep, that's true. Now, when we're talking money, every adult that walked in paid how much? $7.25 for each adult. Plus, every kid that walked in paid how much? $5.50 for each kid. And how much did they pay altogether? $52.75. There's your two equations. Now, I am honestly going to my phone and putting it in calculator mode because I think I might need my calculator, okay? I'm going to solve this. I'm going to use substitution. Oh, that's because that's what we were doing here. When I look at this first, A plus K equals 8, I'm going to solve for K. And I get, oh, well, I probably should show you how I did that. Okay, I'm going to subtract A. All right, right now I got to be honest, my cat is trying to get on the screen. Not making me happy. So I'm going to put 8 minus A in for K in the other equation. So I have 7.25A plus 5.50. What am I putting in place of K? I'm putting 8 minus A. So I have 7.25A plus, oh, see, I needed that calculator, 5.5 times 8. If I was a true math teacher, I could do that in my head, couldn't I? 44 minus 5.5A equals 52.75. I just did the distributive property. Purple pen, purple pen, purple pen. Whoops, it didn't switch. Over here, I want to add the like terms. I want to take 7.25 minus 5.5. I would love to do that, but so far I haven't hit the right buttons yet on my phone. 7.25 minus 5.5. I get 1.75A plus 44 equals 52.75. Okay, the cat is starting to drive me crazy, guys. There's our secret word. The cat is driving me crazy. That's a secret phrase. All right, I have 1.75A, and I've got 52.75. Yep, that didn't work either. 52.75. This is why you should use a real calculator, not your phone. Minus 44, and you get 8.75. We're going to divide by 1.75. I am so almost out of room. And I find out that A, I'm going to put it over here, is equal to 5. So what does that tell me? There were 5 adults. Now, if there were 5 adults and the adults plus kids were 8, the kids were 8 minus the adults. So the kids would be 8 minus 5. So there were 3. We're going to put students here because that was the actual question. We do not write this as an ordered pair because doesn't make sense. It's just a story problem. So there's 5 adults, there's 3 students. Bada bing, bada boom. Next problem. Is it a solution? We've been doing this. This is called, is it a solution is just check. Okay, we're going to check to see if it is a solution. We're going to put 5 in for x and negative 8 for y. So over here, I've got y equals negative 4x plus 12. So y is negative 8, x is 5 plus 12. Over here on this side, I have arithmetic to do. So I've got on the left, negative 8 equals negative 20 plus 12. Does negative 8 equal negative 8? Yes. So now I need to put it into the other one. The other one is 2x. Well, that's supposed to change colors. I'm not very good at that, am I? 2x plus y equals 2. So for x, I'm going to put 5. For y, I'm going to put negative 8 equals 2. Does 10 minus 8 equal, that's supposed to be a positive 2. Write the problem right. Don't you hate it when people write the problem wrong? 2 does equal 2. Check. So is this a solution? Yes, it is a solution, okay? For the other one, new colors, I've got y equals x minus 13. Y is negative 8. X is 5 minus 13. So over here on this side, I've got arithmetic to do. 5 minus 13 is negative 8. So do they equal each other? They sure do. Then for the second one, I've got 2x plus y equals negative 2. X is 5. Y is negative 8. Does 10 minus 8 equal negative 2? It does not. So no, it is not a solution. The left side has to equal the right side for it to be a solution. Okay, so here's your checkpoints. You're going to try these by yourself. 1, 2, 3, and 4. I'm not going to say anything else. It's the last slide. You're going to do these. Look and see. I am going to say more. You know I can't ever shut up. This one already has a value for x. This one does not. Look at 2, 3, 1. Ooh, that looks good. Solve for that y. 1. Ooh, solve for that m. 2, negative 1, 4, 1. Ooh, solve for that d. Hint, hint, hint. Have fun. I believe the secret phrase was, the cat is driving me crazy. So draw a picture of a cat. Whiskers. Little happy cat. There's his little tail. And he's got some spots on him. Okay. There's the cat. Have a great day.